Morning, everybody. On behalf of VHNSN College, Virudhunagar, Tamil Nadu, and the Foundation for Educational Excellence, Bangalore, India, we welcome you all to this national webinar on the topic Recent Trends in Energy, Environment, and Technology. It's my pleasure to welcome Dr. N. Virudhunagar, HOD of Physics, ICSA Additional Coordinate.
Mute பண்ணிருங்க எல்லாரையும். Just a minute, sir. Other mics are Madam, welcome address. It's my pleasure to welcome.
It's my pleasure to welcome Dr. N. Virudhunagar, HOD of Physics, IQSA Additional Coordinator. He is having more than 25 years of teaching experience and 20 years of research experience. He is a dynamic person with updated knowledge. Now I welcome Dr. N. Virudhunagar sir to deliver the welcome address.
Good morning to one and all. It's my pleasure to deliver the welcome address for this national level webinar on recent trends in energy, environment and technology. And VHNSN College Virudhunagar is well known for organizing such seminars and conferences. And in this pandemic situation, we are arranging it as a webinar for the benefit of the academic fraternity. First of all, I welcome our principal who is going to deliver the felicitation address and formal inaugurating the session. Our principal, Dr. Professor Captain P. Sundrapandian, who is always in the forefront, leading us in all our academic endeavors. Welcome you, sir. And I welcome our beloved Pro Vice Chancellor of Dayananda University, Bangalore, Professor K. Muthuchelian, who has always been inspiration for us, is guiding us in all our endeavors. Welcome you, sir, for delivering presidential address and keynote address for this webinar. And I welcome the resource persons for this morning, Dr. Jayakumar, Dean Research and Associate Professor of Physics of VHNSN College, Virudhunagar, who is to deliver a lecture on renewable energy and overview. And Professor Dr. P. Tangavel, who is Assistant Professor of Department of Environmental Science, Periyar University, Salem, who is joining us to deliver his address on environment and human health in this Anthropocene era, who is joining us from Salem, Periyar University. I welcome Mrs. M. Monisha, who is joining us from Chennai, who is the Assistant Professor of Department of ECE in the Wales Institute of Science and Technology and Advanced Studies, Chennai. And she is going to deliver a lecture on cognitive radio networks. And I welcome all the resource persons for this webinar. And I welcome all the participants who is joining this webinar all over from the globe. And overwhelming response from the participants itself shows the success of this webinar. I welcome you and all. Thank you.
It's my privilege to welcome our beloved principal, Dr. P. Sundrapandian, who is the prime motivator for such programs. He got so many degrees in his name from Arts and Management. He is the Best Teacher State Award winner and the Best NCC PO National Award winner. He has around 30 years of teaching experience and 25 years of research experience. I welcome our principal to deliver the welcome address.
Inaugural.
Okay, good morning, professors, Professor Muthuchelian sir, and learned professors and all the participants. It gives me immense pleasure to extend to you all a very warm welcome to on behalf of VHNSNC College Autonomous Virudhunagar for this national level webinar on energy, environment and technology. Our college always remain a forward-looking institution. This webinar is conducted in collaboration with PAL Foundation, a foundation for educational excellence, Bangalore. Thanks to Dr. K. Muthuchelian sir, Pro Vice Chancellor, Dayananda Sagar University, Bangalore, for being a part of us, and best wishes to all resource persons, Dr. Jayakumar, Dean Research of VHNSN College, Dr. P. Thangavel, Assistant Professor, Department of Environmental Science, Periyar University, Salem. Mrs. Monisha, Assistant Professor, Department of ECE, Wales Institute of Science and Technology and Advanced Studies, Chennai. We know energy has been the engine of nation's development, and this has driven the mankind towards growing energy needs, in particular for transportation, agricultural and industrial activities and buildings. And this is the reason India will overtake China as the largest growth market for energy by late 2020s, with the country's energy consumption growing by more than 4.2% per annum, the fastest among all major economies of the world. Renewable energy and its role in energy future is an intense topic that spans across all corners of the energy spectrum. This webinar will pour more insights into renewable energy, environment, and human health and cognitive radio networks. At outset, I am immensely happy to inaugurate this fabulous webinar on recent trends in energy, environment, and technology. Wishes for all success. Thank you.
It's my pleasure to welcome Dr. P. Muthuchelian, Pro Vice Chancellor, Dayananda Sagar University, Bangalore, and former Vice Chancellor, Periyar University, Salem. He has more than 30 years of teaching experience and 34 years of research experience. Under his valuable guidance, 40 students completed their PhD. He has completed more than 30 projects funded by national and international agencies. He is a relevant international scientist. He got many awards and recognitions in national and international level. I welcome such an eminent person to deliver the presidential address.
So very good morning to all. At the outset, I would like to thank the VHNSNC College, Virudhunagar, being organizing the important national webinar on recent trends in energy, environment, and technology. And before that, my hearty welcome goes to the illustrious and the dynamic principal of the college, Dr. Sundarapandian, and the head of the department of the physics, my good friend Prithvi Kumaran, and the organizer of this important webinar, my beloved brother, Dr. Jay Kumaran, the Dean Research of the VHNSN College, and the Pearl Foundation, and distinguished the organizing committee members, Pandirajan, Lawrence, Prem Sankar, Prakash, then Alagu Lakshmi, Periya Karpaya, Siva, and my dear young colleagues of North to South, from Kashmir to Kanyakumari, from Bharat Singh to here, and ladies and gentlemen. It gives me an immense pleasure to be associated with self, and we have been talking a lot about the energy, the crisis, and what are the remedies for the energy all. And today, we know that our fossil fuel reserves will be in the world, especially for the coal, in another 125 years, and diesel, petrol, and other allied, the petroleum products will be in the world for another 40 years. So after that, what we are going to have in the world for our next generation is a question mark. So realizing all the situation of the worldwide problem because of the environment and etc. And the only solution now we have been talking of today is the renewable energy. So renewable energy has become one of the most important factors and hope for the world and to preserve the prime environment and the planet resources for the future generations. So here the India has been taking a lead in the entire globe, I can say world, on this front, showing the developing nations of the world a way forward for the socio-economic growth without the degradation of the environment. So here the renewable energy has as taking a lead role for the alternative our conventional fossil fuels resources. So here, India is very ambitious in its targets, promoting the renewable energy, which includes solar, biomass, wind, and other the agriculture-based biomass sources, as called as the renewable energy, which has started playing an increasingly important role in the accommodation of the grid power, and which finally provides the energy access and reducing the consumption of the fossil fuels. So which altogether helping India to pursue, that is most important, is the low carbon the development path. So ahead of the COP21, India submitted its intended nationally determined contribution, in abbreviation we call the INDC, to the UNFCCC, and outlining the country's past 2020 climate actions. So India, INTC, builds on its the glow of the installing 175 gigawatts of the renewable power capacity by 2022, by setting a new the target to increase the country's share of the fossil fuel based the installed electricity capacity to 40% by 2030. So this was about the target which has been fixed for the Indian subcontinent. So here the INDC also commits to reduce the India's the greenhouse gas emissions intensity per unit of the GDP 33% to 35%, even below, and I can say that in 2005 levels by 2030. So that was the target we fixed to reduce the level of the carbon dioxide. So altogether, to create an additional sink of nearly 2.5 to 3.5 billion tons of the carbon dioxide through the additional tree cover, which also through the afforestation or through the reforestation. So our Honorable Prime Minister Narendra Modi ji, and while addressing the 74th session of the United Nations General, and he mentioned that at New York, said while from a historic and per capita emission perspective of India's contribution to the global warming is very, very low. So India is one of the leading nations when it comes to taking steps to address the issue by adopting the renewable energy policy in India. So as nations contend with increasingly devastating the impact of the climate change. So it's all largely caused by, mainly the reason is the anthropogenic, the developmental activities by the human. Here, the role of renewable energy in the energy and the electricity and mixed together becomes the primary. So across the world, many of the developed and developing countries has started giving the prime importance to rapidly increase the percentage of the renewable energy usage in the overall energy mix of their economies. So this was the target has been taken by the entire globe level to meet its ambitious targets and commitment to the entire world in the fight against the climate change. India has become rolling out the multiple initiatives, the multiple actions, programs, policies, and then incentives to mainly to accelerate the development of the renewable energy sector. As of 31st March, just 3 months before, we had nearly 35.86% of the India's installed capacity of the electricity generation is from the renewable energy. So I think almost we have been targeted and we achieved that, and generating 21.22% of the total utility of the electricity in the consumption in India. So here in the Paris Agreement, India has committed to and intended the nationally determined contribution target of achieving further to a level of the 40% of the total electricity generation from the non-fossil sources by 2030. So this is the target we aimed for the action plan. So the country is aiming for even more ambitious target of 57% of the total electricity capacity from the renewable energy sources in 2027, which has been mentioned by the Central Electricity Authority strategy and then deployment, and also the blueprint of that one. So according to 2027, the blueprint of the India aims to have 275 gigawatts from the renewable energy, and 72 gigawatts of the hydroelectricity, and 15 gigawatts of nuclear energy, and nearly 100 gigawatts from the what you call other zero emission sources. So in the quarter ending of the September 2019, India's total renewable energy in terms of the electricity capacity has been targeted to 130.68 gigawatts we achieved already. So this represents 35.7% of the total installed electricity generation capacity in the Indian subcontinent, which is around 366 gigawatts. So the National Solar Mission was the first one we have been installed in the India and operationalized under the National Action Plan on the climate change in India. So we have a very good source of the grid power from the solar energy and all. And in 2050, the government of India announced a target of nearly 175 gigawatts cumulative the renewable power installed capacity by the year 2022. So we have been ambitious in achieving that one. I would like to proudly say that India has 4th and 5th global positions in the wind and solar power deployment. This is the great achievement in the international arena. So we have been doing a lot since from 2013-14 onwards until to the end of this December 2019, the renewable power deployment has more than doubled. It has been more than and doubled. So the main target have been achieved with the help of with the AGS of the Ministry of the New and Renewable Energy. We also have been installed many energy efficient solar green buildings since from 2009 onwards. I think my good friends here, Jay Kumaran, is doing a wonderful activity in this regard regarding the solar power systems in South Tamil Nadu. And the Sendi Kumar Nadar colleges have been doing a lot of wonders in the solar power utilization and solar thermal the technology in South India. So here I would like to mention that not only the solar energy and also the wind power in India began from the 1990 onwards, which has significantly increased in the last 5 years. Among the various states, Tamil Nadu, Maharashtra, Gujarat, Rajasthan, Karnataka, Andhra Pradesh, and including Madhya Pradesh have been taking a lot of initiatives bringing the wind-based power in the total the contribution from the renewable energy sources. And in addition to that, India also has an ideal environment for the biomass production. And given its the tropical the location, and we have the abundant source of the biomass from wood, agricultural residues, and so many other the bio-based one also is taking a lead role. So according to the IRIDA, biomass is capable of supplementing the coal of the tune of about nearly 260 million tons, which have been saving about 250 billion of the every year. So it is estimated that the potential use of the biomass energy in India, which includes 16,000 megawatts from the biomass energy. So altogether, the India is taking a lead role and utilizing the renewable sources in the entire country. And come to the point of the environment. The second aspect of our dealing is talking, and my friend Dr. Thangavelu is focusing on the environment sustainability. So before making the environment sustainability, we have to think of that, what are the current problems, how we can abate all those problems. That is more important. So here our environment is constantly changing. Every day is changing. There is no denying that. However, as our environment changes, so does the need to become increasingly aware of the problems that surround it, what we have been focusing on the day to day. So altogether, we have a variety of the problems in our planet, So our planet is poised at the brink of the several and severe environmental crises now. The current environmental problems makes the vulnerable to disasters and the tragedies which has been kept happening every year because of the human-based actions. So major current problems which focus in the global and also the environment in India, which focus on the pollution. The pollution, what we can say that the land we live, the water we drink, the food we eat, we consume, altogether one way or other, it has been a serious problems which are not for the conducive for the human. And because of the greenhouse gas emissions, overpopulation, natural resources depletion, the waste disposal, the climate change, the loss of the biodiversity, the deforestation, and then ocean acidification, the ozone layer depletion, the urban sprawl, public health issues, and then genetic modification of the food technology. So altogether, which what we have been currently facing, the recent one is related to the health issues, the recent pandemic issues. So here, the coronavirus disease, and we call it as the COVID-19, is an infectious disease caused by severe acute respiratory syndrome. The coronavirus, we call it the SARS-CoV-2. So it was first identified in December 2019 in China, Wuhan, and has resulted in the ongoing pandemic. Is a serious problem in the global level. So no medication or vaccine is approved to treat the disease. And still the international research on vaccines and medicines for the COVID-19 is underway by the government organization, academic groups, and industry researchers and all over the world. So I think the World Health Organization have been suspended the use of the current hydroxychloroquine and from its global drug trials of the COVID-19 and the treatments on 26th May 2020 due to the safety concerns. So it had previously, enrolled that 3,500 patients from 17 countries in the solitary trial. So still working is going on all over the developed the countries. And then now I think we have to the scientists, and also I am appealing to the young scientists in this webinar, and then you have to take a major and real role to identify or the drugs from the phytochemistry and from either from the synthetic or from the phytoplants, and then also you have to find a alternative solution for the vaccine that should be delivered. I think this is the one of the appeal to the young engineers here. And the other one, the topic of the today's discussion, with having the trial on the technology. So what emerging technologies or technologies whose development, the practical applications, or both are still, largely unreal.
University, Salem. He is having 8 years of teaching experience and 21 years of research experience. He has visited many foreign countries as visiting scientist. He is a reviewer of many scientific journals like Elsevier and Springer. I welcome such a great researcher to deliver a lecture on the title Environmental Human Health in Anthropocene Era. Welcome you, sir.
நான் எப்போ கையில கால் பட்டு தெரியும்.
Thank you, sir. Hello. 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 Hello, Mr. Tangavel, sir. Volume கேட்கல. Yes. சார் தங்கவேல் சார் சரியா வரல நினைக்கிறேன். நானே ஆரம்பிச்சிடறேன் சார். ஒரு நிமிஷம்.
Okay, total
it's 16, 20 minutes. That's why in settings that's better. Automatically it will change to your view.
Then later we can club, edit and club.
Yes.
Thank you. Thanks.
Hello. Yes.
I'm sorry for the inconvenience. Now it's the time for the technical session. For the first technical session, I welcome Dr. N. Jayakumaran, Associate Professor and Dean Research of our college, who is expertise in renewable energy and thin film research. He has more than 25 years of teaching experience and 20 years of research experience. He has delivered more than 500 lectures on renewable energy. Now, I welcome him to deliver the lecture on renewable energy on overview. Thank you. Welcome, sir.
Hello. Good morning. Good morning. I am very much thankful to our college principal, Dr. C. Sundarabandya, and for this who give the permission to arrange this wonderful seminar from our college with the collaboration with the PL Foundation, the Educational Excellence team, guided by Dr. Muthuchandin, the Pro-Chancellor of Dayansagar University, Bangalore. So I am very much thankful to both the motivators of this education-related concepts and meetings. Today is environmental. 3 days back we have celebrated the World Environmental Day. So on this juncture we are going on having this type of a webinar on the topic of renewable energy and overview and environmental related topic and technology. So first topic is on renewable energy and overview. So what is renewable energy? Generally we are categorizing the energy sources in two categories. One is renewable energy sources and another is non-renewable energy sources. It is basically the energy coming out from the decay of, without decaying any source, that is called renewable form of energy, which is responsible only just a very little amount of carbon or sulfur or nitrogen oxides towards the environment. So these are all non-polluting sources, but giving energy to the run the equipments of all the things that is done by electricity. Also, it is not the reason behind the global warming, because the main thing of the environmental issue is global warming. The global warming issue is a major factor. That much of global warming related effects will be reduced very, very less amount, around some 3 to 4% of carbon dioxide will released by the renewable energy sources towards the environment. That's why the renewable energy sources and related area, particularly the biomass, solar, wind, hydro, and the tidal energy, and geothermal energy, and somewhere we call the nuclear energy also a type of renewable energy source. So these type of renewable energy sources are major environmental friendly, eco-friendly sources, which is having a very much boost and awareness among the public and among the government and the countries. So today, why the renewable energy? Why renewable energy? The electricity from fossil fuels puts carbon into our atmosphere. For example, to produce the 1 million watt hour of electricity from a coal, we have to release some 1,500 lbs, some 800 kilogram of carbon dioxide towards the environment, which will be the major cause to increase the global temperature around some plus 0.18 degrees centigrade per year. But the renewable energy releases a very, very less carbon, that is below 3 to 4%. It will be equivalent to 0 lbs. That is to produce the 1 million watt hour of power from a renewable energy source, whether it is a solar, whether it is a biomass, whatever it may be, that will be released very, very, very less carbon, that is equivalent to 0 lbs. That's why the renewable energy is a eco-friendly concept, which will very much green energy concept of energy sources. So, by using the fossil fuels which are available below the earth, that is the coal, oil, and natural gas, and related fossil fuels, will the major cause for the global warming, which will these are some of the side effects, the major effects of the global warming effect. That is the changing rain and snow patterns, stronger storms, rising sea level, damaged corals, and warmer oceans, more droughts and wildfires. These are all the major cause for the past 150 years due to the use of the fossil fuels, the coal, oil, and related concepts. So to avoid this, we have to switch over to the renewable energy in very important thing for the current situation. This is the picture shows how much CO2 emissions, that is the high emissions, the red indicated the high emissions of CO2 emission from the developed countries. Particularly the developed countries emit more carbon towards the environment. Particularly the US and Canada and Russia and China and Australia and England and UK and European countries, they are all called as the developed countries. The developed country use more energy. The developed country use more energy, fossil fuels, so they release more carbon towards the environment. But the impact is mostly on the undeveloped and developing countries. That is the picture shows. That's why we are all switching over to why renewables and the main impact factor, the climate protection. That is to avoid the air, water, and soil pollution, and also which will support the economic development. Particularly using natural resources, our economic development has to be improved. Using the import savings, the green jobs, and impact on rural employment, and stimulus for innovation and development. These are all the basic and important concepts supporting the economic concept of a country, financial concept of a country by using renewables, and also the energy access and security, improved diversity, and reduced exposure to the volatile world energy prices. That's why these are the important concepts in three-dimensional area: climate protection and economic development and energy access and security. These are all the major renewable energy sources: solar, wind, biomass, hydrogen, geothermal, ocean, and hydropower. Solar energy technology, let us start with solar energy. Solar energy we have categorized into two. One is solar photovoltaic, another is solar thermal. That solar light energy has to be converted into electrical energy. That has to be used for home lighting, home electrifying, and industrial lighting, and all other electrical applications and electronics applications. But solar thermal energy is using of heat energy. We can use cooking. We can dry the products, we can heat the water, and room heating also possible, solar refrigeration and solar power generation. All these concepts are very common in solar thermal energy. So solar energy can be commonly, we can notified as solar photovoltaic. But in solar, there are two categories: one is solar thermal, another is solar photovoltaic. This is the solar thermal application. The basic principle is collectors. To collect the heat energy, we have two types of collectors we are using commonly. One is concentrating, another is non-concentrating. In concentrating, we are using CPC, the parabolic dish and parabolic trough and solar tower concept to produce the solar thermal power, and also the non-concentrating flat plate and evaporator, that is the ETC. These two concepts are used in solar cooking system. These are some of the models of the solar cooking models. There is a box type cooker and focusing type cooker and tube model steam producing solar cookers, which is used for large scale cooking process. This is a solar water heating model, so we can use this for from 150 liters, that is 100 liters, to home making hot water system, to large scale 1 lakh liters of hot water can be produced for industrial purposes, for dyeing industries, for medicinal industry, for pharmaceutical industry, hotel industry, hostels and hospitals and all this area, textile industry and fertilizer industry. A lot of hot water can be produced with the help of solar hot water systems. This is that one is the solar hot water system using the flat plate collector, using copper plate as a thermal conductors. Here is the solar tube collector, that is the evaporative collector. This is the new technology used for the past 10 years to 15 years, which used for the, even if it is water has a good salinity, that can be used, that type of water can be heated up by this type of evaporative collectors. These are all solar dryers to dry the food product with hygienic and fast method. Here I am showing some of the pictures of the solar dryers using the food grains to dry up and the fish products to dry up. And another one is the below left is the tea dryer, which is on the setup on the roof of the tea industry itself. And the right below is from a match industry to dry the matchsticks using solar dryers. They can produce they can heat up the air using solar collectors, and that hot air has to be used to dry the products using different techniques. This is a solar thermal energy solar still. Another word, it is called a solar desalination system. We can evaporate the contaminated water. That contaminated evaporated water has to be gets condensed at the bottom of the sloped top surface. That condensed water has to be collected in a drop by drop in a purified at some tank or somewhere. Per square meter area, we can collect 3 to 5 liters of distilled water per day using solar desalination system. So this is a concept, very cheap and easily portable equipment. This is a model to collect the solar desalination to get the purified water. This is another concept of using solar thermal energy to produce the power generation from solar towers. But it requires a lot of heliostats, that is called the reflectors. Large number of more than thousands and 10,000s of heliostats has to be focused towards the top of the tower to heat up the high pressurized molten steam, molten liquid to produce steam, high pressurized steam. That high pressure steam to run the turbines to generate electricity. This is only the California desert to making electricity. In solar thermal applications, the solar hot water system, solar cooking system, and solar dryers. These concepts are mostly utilized in India. But in this type of solar power generator and solar desalination system are mostly used in Western countries, particularly in desert areas, to produce power using solar thermal. Next concept is solar pond. This is a concept of storing the solar thermal energy by developing a different gradient water pond. This is an artificially developed solar pond. There are 3 basic zones. One is surface convective zone to absorb the heat energy. Second is non-convective zone to act as a insulator layer, and the bottom is a convective zone that can trap the heat energy for more than 2 to 3 days. From that heat energy can be absorbed through some other heat exchanger pipes to produce steam, to produce electricity or some other thing. The top layer at an ambient temperature, whereas the bottom layer at the 60 to 85 degrees centigrade. Normally the top layer will be at the temperature of 4 to 5 degrees centigrade, lesser than the atmospheric temperature. But the surface convection zone will convect the heat energy to the bottom, and the second is concentration gradient zone. There is a concentration difference at the different 3 layers. The lower convective zone that has a higher concentration liquid that can trap the heat energy. That trapped heat energy can be stored for 2 to 3 days. That heat energy can be utilized to produce the power generation. But this one is one of the toughest and high maintenance required technology. So many of the countries are in a trial basis. They are running this type of technology. In Pondicherry, they have tried this type of technology some 15 years back, and southern part of this is in the University of Texas. They are working on this type of solar pond using different liquids and other things. This one is solar energy powered steam cooking at Mount Abu at Rajasthan. They are using the largest, one of the world's largest steam cooker. They can produce 35,000 of meals daily using the solar steam power. It's the energy is free, so they can produce free of cost, one-time investment. And this is the largest solar photovoltaic power plants in India, particularly. Using light energy, we can produce solar photovoltaic current. In the world, we are having largest solar power plants in the world. In India, we are having at Kamudi in Tamil Nadu, southern part of Tamil Nadu, we are having 648 megawatt solar power plant. That's 40 kilometers from our town. But China is leading in all the area. China's Dengar Desert Solar Park is producing 1,547 megawatt. In our nuclear power plant, we can produce some 1,000 megawatt in single plant, 2,000 megawatt in 2 plants. 4 more plants are coming up. So, but in solar, the area is large, but the power is very cheap and cost-wise. That's why these many countries are working on solar power plants in large scale in deserts and particularly unused agriculture area. They can install the largest power plant to produce the solar power. This is the 1 megawatt solar power plant for 6 storage at Brahmakumar. That is the picture I already shown. This is the solar cell technology. In photovoltaic system, that is basically we are categorized into 2. One is grid connected, another is ungrid connected. That is called standalone photovoltaic system. That grid connected PV system has to be directly connected to utility or biomodel photovoltaic system, or without store or without, that is we can store the power in the batteries, or without batteries we can use it in daytime model. Another one is standalone photovoltaic system. That also has to be categorized into without battery and with battery, and also along with the hybrid with the turbines or with the hydro turbines or with a diesel generator or with some fuel cells and other things. So these are the general models for the photovoltaic power systems from the home to the industries and to the power generations. These are the different solar power plants and the rooftop model. Generally, solar power plant in India, our government Ministry of Human Resource and Development, that is the MNRE, Ministry of New and Renewable Energy Development Agency, they are concentrating mostly on rooftop solar power plants. Wherever the rooftops are free, they can utilize that area to produce the solar power. Around some more than many gigawatts of solar power has to be produced from our country. This is many solar power plant, solar photovoltaic applications in the area of electric car charging and electric boats and electric ships. And in military purpose also, they are using solar photovoltaic portable solar panels to equip their radio walkie-talkies and their electronic equipments on the move. And floating solar panels also utilized in the floating solar gardens and are made in some foreign countries. The top picture shows the India's largest solar power plant in a single area, some 638 megawatt, 48 megawatt in Tamil Nadu. And at the bottom is the Cochin Airport, which is the only airport in the world is powered 100% from solar. It installed in the year some 2030, I think so. This one is in Japan. In the top, floating solar panels. They can produce around some 2 gigawatts of solar power from that lake using solar floating plants. And bottom one is from Singapore. They are using also solar power. Singapore is just 50 square kilometer area. So it's fully surrounded by oceans and coastal area. So they are using the solar floating panels to produce solar power for their country's own purpose. They are purchasing 100% from Malaysia. This one is from South Korea. Around some 35 kilometers of highways is in center path is covered with solar panels. The center path is used for two-wheelers. And at the bottom is the solar powered railways in southern part of USA. And this one is China. This road has to be opened last year only, 2019 beginning. The city of Jinan, the home to Solar Expressway, covering 5,875 square meters. The panels on the road can produce 1 million kilowatt. That is 1 megawatt hours to power 800 homes in a city. This is at in India, in Kerala. Hello. In India, in Kerala, they are using solar power plant and floating technology. Next, wind energy is another concept of bioenergy. There are, around some 4 to 5 meters, that is around some 5 to 10 kilometers, 5 to 20 kilometer wind speed is utilized for the wind power generation. In India, the Western Ghats, particularly the Western coast is suitable for wind power generation. In Indian power capacity, we can produce two types of windmills around world over. There are two general models, horizontal axis and vertical axis windmills commonly using. These are the different windmill types throughout the world. They are commonly used, vertical and horizontal axis windmills. We can install the windmills through in any place, in anywhere, but it's purely site dependent. We can get throughout the year around some 5 to 20 kilometer speed, uniform wind speed, and non-cyclone prone area is very suitable for wind power, particularly the coastal area, the valleys and the hill slopes and that deserts. These are all suitable for the wind power generation. Then next one is bioenergy, another concept of renewable energy. We can produce the bioenergy from biomolecules using fermentation or some other organic materials such as trees, plants, including crops, and other waste materials, wood waste from mills, municipal waste, and manures and landfill gases. These are all useful for to produce bioenergy, that is biopower, bioheat, and biomass combined heat and energy, and biofuels and bioproducts. Our railway department are working on the biofuels for the rail engines to run using biofuels, and biomass based concept commonly known as the biogas. But other than biogas, we can use our food waste from our kitchen waste can be used to produce the biogas from in the minimum level. Per 2 kg of food waste can also be used to produce the biogas in our kitchen for our home purpose itself. So dry biowaste and wet biowaste, and two categories has to be used to produce bioenergy, and the oil content of the biological waste has to be used to produce the biofuels. These are all the basic concepts of biomass conversion technology. There is the direct conversion and advanced conversion techniques. There is the combustion and gasification pyrolysis technique has to be used, and different subcategories to produce the biomass gasifications and biogas gasifications techniques. So these are all the aerobic and anaerobic digestion concepts, and different floating and unfloating fixed dome concept, and different techniques has to be used to produce the biomass or biogas from agricultural residues and organic waste and sewage waste and forest residues and animal manure and our kitchen waste and other things. So the cost of clean energy, commonly we can compare with the different types of clean energy. The photovoltaics to produce the maximum cost diverse measures to prevent 1 ton of CO2 emissions in euros. That is 611 euros it will for photovoltaic. For biofuels it is 585 euros, and for geothermal 540 euros, and for euros, 1 euro is equal to around some 70 rupees for Indian rupee. For diesel cost and wind power, it is 91 euros. For solar thermal is a little bit cost effective. That is comparing with solar photovoltaic, its efficiency is a little bit high. Solar photovoltaic efficiency will be around some 20 to 28, 26% in common, but solar thermal energy will be around some 60 to 65% in common. That's why the cost effective comparing with solar photovoltaic, solar thermal energy will cost effective, and in particular nuclear will be the most cost effective comparing with all cleaner energy, because it is also it is only hazardous to the radioactive pollution, but comparing with the air and water and soil pollution, nuclear will be the better option comparing with other clean energy. But the maintenance is a little bit cost, but cost effective it will be around some 7 euros. That's why the nuclear energy is another advantage is the land use. Around some 2.4 hectare of land is enough to produce 1 megawatt of power. For example, for the solar photovoltaic, around some 36.9 hectares area is utilized. That's why nuclear is also a growing concept in the name of green energy or renewable energy. So in United States, in the world, around some 442 nuclear reactors are working there, and United States itself around some 101 nuclear reactors are running. For in India, around some 12 reactors are running. That's why we are very much lagging on energy and power production. This is another picture shows the number of reactors under construction in countrywide. China is constructing around some 25 reactors now. Russia is constructing around some more than 10 reactors. India is constructing some 8 reactors now. That's why many countries are working on that nuclear energy power generation. In France, around some 80%, some 70%, or more than 70% of electricity has been generated from nuclear energy. In India, around some 2 to 3% has to be produced from nuclear energy. Number of nuclear reactors worldwide by age, around out of 442 nuclear reactors, around some more than 200 reactors are of the age of 30 to 33 years of running experience. This is the world energy consumption for around some 79% from fossil fuels, and nuclear is around some 14.8%, and renewable energy is some 18.1%. Share of electricity consumption is more than biomass, around 78%, and solar and other things are a little bit low. This picture shows the Indian power capacity. Around some 53.6% electricity has to be produced from coal, and gas 6.7%, and renewable energy we are producing, as our chief guest told, around some 35.9% from renewable energy. In that renewable energy, hydro is around some 12.2%, and wind power is 10.1%, and solar power is around some 9.76%, and bio is around some 2.5%, and waste to power 0.04%. This is our wind power capacity. In India, Tamil Nadu is standing first to produce more wind powers. We are having some 9,232 megawatt of wind powers in southern Tamil Nadu, particularly the Western Ghats. The slopes of Western Ghats are very much naturally gifted with wind power. That's why we are having a lot of wind power, wind mills on that hilly slopes of Western Ghats, from Coimbatore to the tip of Tamil Nadu, that's Kanyakumari. And Gujarat stands second, some 7,200 megawatt from wind power, and Maharashtra third, and Karnataka and Kerala and like that. It is the renewable capacity investment by country from 2010 to 2019 in US dollars. China is investing more and more on renewable energy related projects and other things. They are investing some $758 billion towards renewable energy, and the United States 356. Simply you have compared these two countries. China's population is around 142 crores, and US population is 34 crores. Our population is 139 crores. That's why, but the energy production, our saturation is our investment is there, which shows how much these countries are still stand as a developed country. This is the new capacity added in India across technologies in gigawatts in fossil fuels from 2015 to 2019. That is in first half year of 2000, second half year of 2015, and the first half year of 2016, and first, second, and half years of the concerned years. In 2019, in the first half year, we are around some 4.5 gigawatts total renewable we are investing, and after that 3.5 gigawatts from solar, and 1.2 gigawatts from wind energy. And this is the components of levelized cost of energy. Onshore windmills cost and solar photovoltaic utility cost in US dollars. For photovoltaic, it will be for rooftop, it will be around some $150, and for rooftop residential, it will be around more than $180 to $200, and battery storage, it will be a little bit cost, more than around some $300. That's why the cost-effective technology has to be utilized, cost-effective research has to be more funded towards renewable energy. This is our work on renewable energy related areas. We have invented some few charger-based solar-powered charger, and many hybrid solar and wind-based solar chargers, and many electric cycle with the support of 12-volt circuit. We can convert the 36-volt engine to run by 12-volt support. And we have conducted many programs, in particularly with the support of central government, state government fundings, and our great professors, Dr. Muthuchiran and the School of Energy Department of Mother Commerce University. They are guiding towards the renewable energy area. So with this support, we have conducted many seminars and programs in our college for the last 12 years. We are also giving more consultancy and research support to the students from schools to colleges and TV programs and radio programs towards renewable energy. Our college also supported with the solar power or some 12 kilowatt solar power and the solar thermal system of water heating system also some more than 1,000 liters. So this is our Abdul Kalam's word, that is our contribution to promotion of energy utilization is a major share which can bring the energy independence much earlier than 2020. So energy utilization is a major concept with the support of energy in the word energy utilization. Renewable energy is a major share which will promote the energy utilization to bring our energy independence 2020. But till now we are in lagging of energy and so depleting in that concept. But in 2022 we will get in the accepting this word. So thank you.
Thank you, sir, for your interesting and informative presentation. From your presentation, anyone can easily understand how to harvest renewable energy in a very simple and effective way. Thank you, sir.
Any questions, please? Kindly post your questions in the chat box. I think one question from Sendil Kumar. Any relationship with the solar panel versus our environment threat? Yes, solar panels are mainly manufactured from silica. That is mostly utilized in the manufactured solar concept. Solar panels, solar cells has to be prepared from silica, germanium, and some cadmium telluride and like some alloys and but commonly used solar cell is from silica. Silica is around some efficiency that is in three categories. Crystalline silica around some 26%, single crystal silica, and polycrystalline around some 18 to 20%, and amorphous silicon will be less than 10%. But this silica is it is a common form of another form of sand, that is a purified form of sand. So it is not a bigger threat to environment. So we are should not be panic in that area. Some other questions, you can post it in our chat box. Thank you for our team members, and thank you for Dr. Muthuchelian sir and our principal Dr. Sundarabadian sir and our HOD Dr. Pradeeparan sir for their wonderful support towards this wonderful webinar. Thank you, Honorable.
Thank you, sir. For the next technical session, I welcome Dr. P. Tangavel, Assistant Professor, Department of Environmental Science, Periyar University, Salem. He is having 8 years of teaching experience and 21 years of research experience. He has visited many foreign countries as a visiting scientist. He is a reviewer of many scientific journals like Elsevier and Springer. I welcome such a great researcher to deliver a lecture on the topic Environmental Human Health in Anthropocene Era. Welcome you, sir.
Thank you.
Sir, தெரியுது, ஆரம்பிக்கலாம்.
Good morning to Honorable here. First of all, sir.
Thank you. கேக்குது and people
ஆரம்பிக்கல. ஸ்லைடு தெரியுது சார்.
ஸ்லைடு தெரியுது.
Okay, sir. Okay. Thank you. So, good morning to Honorable here. First of all, I would like to thank Principal of VHNS College and the Program Coordinator Dr. Jaikumar sir and my mentor Professor Dr. Muthuchelian sir, our former Vice Chancellor Periyar University and presently a Pro Vice Chancellor in Dayananda Sagar University for giving me an opportunity to share my views on the environment and human health in the Anthropocene era. And in my lecture, I would like to briefly explain about the population explosion, how that influences on what are the other factors like over-exploitation of natural resources, climate change issues, how that will influence on the habitat loss and species extinction, and also for the modern agricultural practices that influence on that human health in the Anthropocene era. and the environment and people, these are all interlinked between each other, and people affect the environment by burning of fossil fuels, urbanization and deforestation and the waste generation and all those things, and how the people affect the environment by climate change, drought, water availability, shelter availability and soil degradation and all those things. And now we are facing in that Anthropocene era, and that era was started in the midst of the 20th century, and the problems for the 21st century is so many problems highlighted here. And according to that, the World Economic Forum released by a global risk report recently by 2020, and most of the factors or risk factors belongs to the environmental aspects like extreme weather conditions, climate action failure, natural disaster, biodiversity loss and human-made environmental disasters, rather than the geopolitical, technological, societal and economic factors. And now at present the global population is 7.2 billion, and that will be reached 11 billion by 2011, and the population growth also most vigorously in India and China, and we are surpassing by 2022 to China. At the same time, for the urbanization, and the world urban population is expected to increase by 72% by 2050, and not only in the China and India, it's when compared to that of rapid urbanization rather than the Europe and UK, and across the world nearly 30 to 47 to 60%, nearly half of the percentage is increased. And then coming to the overexploitation of natural resources, and as mentioned by our previous lecture, and Professor Mutsalian sir mentioned about, we need the energy entirely dependent from the coal-based fire plant or conventional energy resources. And India is occupied as the fourth largest coal producer in that world, and also third largest coal consumer in the world. Even though to fulfill the population need 50%, we need to produce more energy, 40% more water and 35% more food. So we entirely depends upon the coal-based power plants for our energy resources. So most of the coal-based mining and other iron ore mining and other minings are in the midst of the forest areas. So the deforestation occurred, and main thing, and most of these minings are in the midst or in the vicinity of the national parks or the sanctuaries and all those things. And recently the government was cleared for license or obtained the environmental clearances in the most of the mining companies. And in such coal-based mining, nearly 250 hectares of the forest was destroyed for such kind of the things. So the coal-based mining is one of the major constraints for the deforestation factor, and almost nearly India-sized tropical forest has been already disappeared in the Amazon area. And how that will affect for our day-to-day environment based on the ecological footprint. The ecological footprint measures how fast we consume the resources and generate waste, and compared to that of how fast nature can absorb our waste and generate new resources. That's the ecological footprint. Shoot day every year. In the earlier 3 to 4 decades before 1970, the Earth overshoot day is December 29, and but for this 2019, July to 29 is the Earth overshoot day, and this is the formula to observe for Earth overshoot day. The Earth overshoot day is nothing but more natural resources will have been used by that day than what the Earth can renew on its own within a year. And so in this scenario, when the persist, the Earth overshoot day will become June 28 by 2030. And otherwise, we need to cut down the carbon emission measures as mentioned by Professor K. Muthichalyan sir in that beginning inaugural session, by the renewable resources and other things. And we need to cut down the carbon emission by reduced 30%. The Earth overshoot day will appear in September 16, 2020. And at the present scenario, we use more than 0.7 times higher than in, and US 5 times higher than that of population. So energy and climate are the key issues. Our former scientific advisor of Prime Minister Dr. Raj Chidambaram has mentioned those things. And on behalf of the COP 21st meeting was held at Paris, and before that meeting, to create an awareness, global awareness about the climate change, former US President Barack Obama visited Alaska, and he is the only US President to visit Alaska before that COP 21st meeting. And some of the film activists, Oscar awardee and Leonardo DiCaprio, and that the girl you knew very well about, the Greta Thunberg, is awardee for the Person of the Year time, and she raised her voice about that the climate change issues. And these climate change issues, not only we have to discuss about our scientific people, and even in that Business Week and other Time magazines, everything they, for the past 2 to 3 decades, they have to speak about our global climate warming and other issues, and how that global warming or global climate change threatens our jewels of nature, Great Barrier Reef. A few examples I would like to mention here. Great Barrier Reef in Australia, it's nearly almost 90% of the coral reefs. It is the richest coral biodiversity, coral reef biodiversity. It's located in Australia, and Venice, the Canal of Venice in Italy, it's dried now, and Kilimanjaro is the glaciers of volcanic mount in Africa, that's also affected. In Machu Picchu, that's also affected by melting of ice glaciers, Mount Fuji. And there is a linear relationship between the global population as well as the CO2 concentration. And first 2013 May 9, that global CO2 concentration was reached 400 ppm. And this is the recent report by NOAA, National Oceanic Atmospheric Administration. It's located at Hawaii. That laboratory is Mauna Loa Laboratory, and they have to observe the weekly, daily, and monthly global CO2 concentration. That is the recent global CO2 concentration around 417 ppm, and in earlier that pre-industrial value is 280 ppm. So nearly 45 to 50% increase when compared to that of the pre-industrial value of CO2 level. And this is the daily and the average monthly average values observed by the NOAA laboratory. And the ultimate take-home message is, and the 50% of the developed nations, they have to 10% of the developed nations, they have to emit 50% of the global CO2 concentration. The remaining 50% of the developing nations, they have to emit only 10% of the CO2 concentrations. So that's why even from the Kyoto Protocol to the Paris Agreement and for the last COP25 meeting, still there is a conflict of interest between the developing and the developed nations, who will contribute much more amount in terms of technology and in terms of amount or the funds provided to the Global Climate Fund, GCF, and that the conflict of interest is going on. What are the impact of these kind of air pollution, and transportation and deforestation is the major constraint. And even though for the air pollution, and everyone knows it because the particulate matter, and that's also the WHO has announced it is a carcinogenic agent. Particulate matter is a carcinogenic agent announced by the WHO in 2015, and every year 7 million deaths occurred throughout the world, even for stroke or other cardiovascular diseases, respiratory problem. And how that particulate matter, it's less than 50 to 70 microns, less than that human hair, how that particulate matter it's accumulated in these blood vessels and other things, and how even though for these particulate matter, it includes or linked with the Alzheimer's disease, and also for the type 2 diabetics, and also for the antibiotic resistance in that recently. And what are the global climatic extreme events, and kind of in recently we have to face a lot of heat waves and cold waves, not only in India or specific continents, even in the Europe continent, mountain area, coastal zones, northwestern Europe, even in Arctic region and Mediterranean region. And this is the selected significant climate anomalies recently occurred in April 2020 in several cyclones and tornadoes, and extreme rainfall pattern even in that Middle East countries occurred, and also for the green melt extent in that area, 60.1 degree Fahrenheit. This is the extreme record. Previous record is 63.5 in 2015. This is the recent record in Antarctic region, and in last year several hurricanes, cyclones and other things throughout the continent, and the extreme weather event, even though for the 10 most cities, nearly 7 cities or 6 cities are Asian countries, especially for the global sea level rise, especially in Mumbai and Calcutta, and we are facing much problem even for the sea level rise. And according to that recent report, that's sea level rise by more than 1.1 meter, and by 2030 the rise by 5 meters, even though that the temperature is 4.5 degrees Celsius or above, and for 2100 it will be between 0.6 and 1.3 meters higher than today. So that's because of melting of ice glaciers in Antarctica and Greenland. And now we are facing the extreme heat waves. That's the El Nino impact. El Nino means what are the changes out in that the surface of the Pacific Ocean. That is the El Nino patterns. And La Nina is cold wave. And both the El Nino and La Nina frequently occurs. That's called otherwise El Nino Southern Oscillation process. And for the past 1 decade, nearly 4 or 5 years are recorded as the hottest year according to the Climate Central report. And this is the most, the red indicates for the warmest, record warmest temperature. The ultimate take-home message is nowadays the season are shifting. That's the ultimate take-home message. Summer extending and the remaining all other seasons, the fall, winter and spring seasons are shrinking or reduced. And what are the problems we faced, even though if we are not below the temperature, to mitigate the temperature up to 2 degrees Celsius, there is a lot of change, melting of this one, global crop decline, crop productivity, mass extinction. Already we have faced the 6th mass extinction, and unprecedented heat wave and questionable adaptation. And even though if for the heat wave or for the cold wave, the ultimate effect is for species extinction. That's why I would like to mention here about the things. And here some of the example, and due to the time constraint, I am not going to in depth about all those things, because for a few example, and between 1.5 degrees Celsius and 2 degrees Celsius, how it impact of that influence, especially in the species extinction. 6% of insects, 8% of plant, and 4% of vertebrate are affected. But 0.5 degrees Celsius increase, nearly it's a double. 18% of insects, 16% of plants, and 8% of vertebrates. Almost double the effect, even though 0.5 degrees Celsius of increase in temperature, and loss of corn yield in the tropic areas, and frequent ice-free summer in the Arctic region. 30% of coral reefs it affects. Additionally, 50% of the global fisheries affected due to the sea level rise, and a lot of weather, even extreme weather events occurred. This is for the 54 weather events, cyclone and other tornadoes and other severe storm events occurred in that. Even for that, now the Syria war is also linked with the drought, climate change problem due to drought season. And first time the Venice Canal also drying up, and migration or refugee crisis is one of the problem for that one. And warmest winter even in Indian scenario, and cold, extreme cold events also occur throughout the world. This is the extreme cold event in Kashmir, and this is for that Jammu Kashmir, and for that other cold waves in India. 974 cold wave events occurred for the past nearly 4 decades, and extreme rainfall pattern in Tamil Nadu is one of the best example. In 2015, we have to received 1,100 millimeter in a single day, and recently for the Ooty, we received 800 millimeter rainfall in a single day, and changed the erratic rainfall pattern. Most of the rainfall in a single day. That's the recent scenario, the changes in the climate pattern. And this is the hurricane and typhoon in Japan and throughout the world, El Nino pattern hurricane, and consequent hurricane Hermia, Florida, Hermia, Maria, and other scenarios. This is the recent extreme rainfall pattern in the Middle East countries like Gulf countries. Even though he never faced such kind of the extreme rainfall pattern previously in the Gulf countries, Istanbul and other places. And this is the extreme severe cyclone. How much of the cyclone formed in India? Even a total cyclone formed 16, and severe cyclone nearly 12 cyclone, 75%, even the Varda and Amphan recent one, and for the Nisarga, the recent one. And what are the changes in that health due to the air pollution or for the emission of particulate matter, asthma, cardiovascular diseases, change in the vector-borne ecology, malaria, dengue, encephalitis, and even for the MERS, SARS, and for Ebola virus, the scientists, they have to proved linked with the climate change issues, even chikungunya and other things, and respiratory problem, several other waterborne diseases, malnutrition, and forced migration, civil conflict, mental health impacts, the recent Syria war and other issues, and heat-related cardiovascular and other things, fatalities. And these are all some of the example how the human health, climate change affect human health, especially in the developing countries like India, and 690 million children are risk in that global scenario. And even though for the agricultural productivity also affected due to the erratic rainfall pattern, severe drought conditions, and new pests and diseases pressure. And that's why the agricultural department, they have mainly focused on the climate smart agriculture and integrate the adaptation, food security, and mitigation policies to increase the productivity and improve the use efficiency and increase the resilience, climate resilience aspects. And the recent scenario, in addition to the climate change, and also it's related with the climate change, like global warming rather than the global warming. And there is a locust plague in otherwise called in Western India. It's a locust attack, mass locust attack, and these locusts across from the African countries, from Kenya to Yemen, Saudi Arabia, Iran, and across the Indo-Pakistan border, and reaches them recently by Rajasthan and Madhya Pradesh. And recently the global senior scientists they have to keep Christmas, and they're changing the wind pattern in India and Pakistan and frequent cyclone in the Indian Ocean. These are all the favorable conditions for the desert locust attack in Indian conditions, especially in Rajasthan, because that good rainfall pattern are predicted during the first half of the June in that border, and this is a very good condition for laying eggs and breeding season. It's the best breeding season, and the sandy soil in Rajasthan is also conducive for laying eggs. So in last they moved from Rajasthan to Jaipur and also Madhya Pradesh, and in the recent report they moved from Madhya Pradesh to Chhattisgarh and other climate change. These are all ideal, even though summer or spring season or for the rainy season, irrespective of the seasons, and they have to adapt their breeding capability, and they have to lay more eggs, and also they have to eradicate even though 1 square kilometer swarms among 35,000 people, and each locust they have to eat nearly almost the same weight, 2 gram the things. And another one, my biggest problem for the agrobiodiversity in the western countries is the decreasing the bee population, which is one of the natural pollinator, the bees, and that was affected by the neonicotinoid pesticides in US countries, US, several parts of the US, and how that climate change influence on the biodiversity resources by deforestation, especially the forest fires. It occurs throughout the world, even in the Himachal Pradesh and Amazon dieback. These lungs of our world, nearly as a richest biodiversity, tropical rainforest, nearly 1,200 millimeter of rainfall, and the recent Australia bushfire, and that is their biggest fire intensity. It is the intensity was more when compared to that of the Amazon dieback and other California wildfire. That's why the loss of biodiversity was more. And if you want more detailed, you can refer with the State of the Plants, World Plants Report 2017. And although several threats to the species with exploitation, habitat loss, and all those things, climate change is only 7.1%, but that will affect more humans due to the human being or anthropocene and anthropogenic influence on this, mostly for almost all the biodiversity resources loss. Why we need to pay more attention about biodiversity rather than us? Because for the global climate change issues, we affect only 32%, but in the plant and animal species that affects nearly 62%. So that's why we need to pay more attention. And a lot of species also declined, according to that of IUCN, International Union for Conservation of Nature and Natural Resources, located at Switzerland. They have to maintain the red data book, and most of the threatened species is rising, especially in the fish and other things. And even though the temperature rise, 1/4 of the species will going to decline, and this is the ocean, how that will affect ocean acidification and other species, and how they influence the climate change in that the biodiversity, shifting habitats, predators decline, shifting migration pattern, migratory bird patterns, and the entire ecosystem changes, and adaptation is also one of the questionable things. And as I have already mentioned, 5 mass extinction we face. Now we are facing the 6th mass extinction in the Anthropocentric. And this is the almost 5th of the world plant under extinction. 21% of the global plant species are already facing extinction. Chocolate is also going to be declined, and mango trees, it's the richest diversity, species diversity. 13 Indian species we are going to become to death, and similarly for coffee could be extinct nearly 2080. And Mexico, Nicaragua, and Tanzania, Arabican coffee, Coffee Arabica, that is the one of the richest coffee diversity in the world, and Arabica coffee could become extinct within the next 70 years because of the pest attack, like in the bean belt areas, the coffee berry borer and other diseases. And this is one of the best example about the global climate change issues on biodiversity. Polar bear, and Zach Unger is a wildlife traveler, and he traveled across the Arctic region, and he never seen a polar bear, even a very long journey. So that's why he wrote a book, Never Look a Polar Bear in That Eye. Then only the IPCBD, they have announced year 2010 as a year of biodiversity, and 2011 to 2020 is a decade of biodiversity, and they have to take several measures to predict that species because of melting of ice glaciers. This is the Arctic melt ice, and it's only going to decline near that species. And another one of the global climate change issues in that Arctic region recently, in that the Doomsday Seed Vault or Svalbard Global Seed Vault. This is the safest storage for crucial plant genes and all the plant seeds storage, and it's located in the permafrost area nearby Norway, and it's also affected by the melting of ice glaciers in that region. And luckily they have taken several measures, protective measures in that the global Svalbard seed vault. So none of the things was affected. So this is one of the reason. And for Antarctic penguin population also going to be decreased with increasing the temperature. And the species extinction rate after that industrial revolution going to be increased even for small birds or different hierarchical status. And 140 species before industrial revolution was extinct, and after the industrial revolution nearly 477 species are going to be extinct, mostly for amphibians and fishes, and the rating of extinction is 14 times higher in mammals, 13 times higher in birds, and 8 times higher in remaining all other vertebrates. And coming to that, the global warming impact on the marine environment, and it is due to the warmer, less oxygen, more acidic. They have to sea level rise that will influence for the wetland habit and other things, coral bleaching, habitats, acidification, fisheries, and due to the formation of carbon dioxide adjacent with the water, carbonic acid formation, they have to clothe the shellfish and other corals. So that's why the coral reefs, when the coral bleaching occurred, see, the past one decade, there is a drastic decline for the coral reef, especially in the Great Barrier Reef, and the consequent global bleaching events was also occurred. And this is the recent scenario, and officially declared by due to the coral bleaching in the Great Barrier Reef, the Melomis rubicola, it is one of the small rat-like animal, Bramble K. melomis. It's an endemic species, mammalian species, exclusively located in the Great Barrier area. and this is officially Australian government officially announced that species it's almost extinct due to the coral bleaching, and how that influence on the turtle population, because the climate change they have to influence the temperature, rise influence from to the population of female rather than the male population. So that will affect for the population things, and also killing starfish and whales change the migratory route, and most offshores of whales happened recently throughout the world. And how the modern agricultural practices, nowadays we use it for fertilizers, pesticides, and other modern agricultural practices. We have to most amount of the input, and several sources, even for grab or groundwater source or ground indoor outdoor air, and the different exposure routes, either knowingly or unknowingly, we have to inhale or enter it into our body, especially for the cadmium. It is one of the notorious heavy metals. Excess application of phosphatic fertilizers, that is one of the major for the cadmium content, and similarly the arsenic levels. Most of the part in Calcutta and Bangladesh, they have even in the rice, it's a type of arsenic, cadmium, in the grain part things. So based on that, nowadays our research in Photonic University, and we have operated on and how healthy instead of cadmium content, and similar to the pesticides applications, lot of
Sir, good day.
Dr. Jaykumar.
Yes, sir. Yes, sir. And the next presentation is coming, sir. Yes, sir.
Yes, sir.
The next presentation is coming. I am very much thankful to Dr. Thangavel for this wonderful presentation in a short period on the environmental issues, and he covered a lot of area. The impact and the effect of environment due to the different kinds of sources and other things. So, next presentation by Dr. Monisha.
Thank you, sir. For the third and final technical session, I welcome Mrs. M. Monisha B.Tech, ME, Assistant Professor of ECE, Institute of Science and Technology and Advanced Studies, Chennai. She is currently pursuing her PhD in software-defined networks. She has authorized more than 50 papers in Scopus in text journals. She is a young and a dynamic researcher in radio software.
Yes, it's a great time to have the final session now. We are having the wonderful technical people, technical resource person, Mrs. Monisha. She is going to give a talk on this radio surface communication related area, that is the correlative radio network. So I welcome Mrs. Monisha, the great engineer from Tech University. Welcome, ma'am. And the session is yours.
Yes, sir. Good morning, one and all present here. Thank you for having me. I'm going to be speaking to you today about cognitive radio networks, which is one of the key technology to overcome the radio spectrum scarcity and to avoid the intentional radio jamming scenarios. So it's widely used in different applications, scenarios of which is one important application is the satellite communication. As Albert Einstein quoted, if you can't explain it simply, you don't understand it well enough. Yes, I'll try my level best to make my lecture as simple as it would be easy to follow by you all. Here is my presentation.
Yes, come and share, ma'am.
Yes.
Yes, it's now visible.
Is it visible? Okay.
Thank you, ma'am. Proceed.
So here is my title of this e-lecture, that is Cognitive Radio Networks. A brief overview, history and introduction, characteristics of cognitive radio networks architecture, its security issues, and cognitive radio network applications, future research directions, and conclusion. So, a brief history. The term cognitive radio, it was coined by Mottola. He is the one who coined the term cognitive radio. What is cognitive radio? It is nothing but a smart radio, we can say. It has the ability to sense the environment. It learns from the history and makes a database of it. And based on the history, the intelligent decisions are made to adjust the transmission parameters according to the current state of the environment. An introduction. Generally, the radio spectrum, it is categorized into licensed and the unlicensed frequencies. The licensed spectrum, in the sense, it is mainly for the use of the designated users or the intended users, you can say. For instance, the ultra high frequencies or the very high frequencies, TV frequency bands. These are all examples of licensed spectrum. The unlicensed spectrum, it can be freely accessed by any user, but see to that you are following some certain protocols. For example, not exceeding a defined limit for the transmission power. For instance, the ISM band, which we use, the industrial, scientific and medical band, and also UNII, unlicensed national information infrastructure frequency bands. These are the examples of the unlicensed spectrum. This ISM band, it can be shared by the technologies. The recent wireless technologies like IEEE 802.11, which is the wireless local area network, and also Bluetooth. The key enabling technology of dynamic spectrum access. That is, the utilizing the spectrum in an efficient manner. That is always a cognitive radio, which can help addressing the inefficient usage of the spectrum. This CR, it is mainly used to exploit the unused licensed radio frequencies. Also, we can tell it as primary users frequencies, often designated as a spectrum hole or the white spaces. This cognitive radio, it aims to enable the secondary users or the cognitive user to access the spectrum hole in the entire spectrum in order to increase the quality of the service. But they should not harmfully interfere with the primary user at a particular time and a given location. This is a picture depicting the spectrum holes. The x-axis represents the time and y the power. The white space here are the spectrum holes, and the blue one indicates the spectrum which is being occupied by the primary user or the licensed user. So these white spaces are used by the secondary users, namely the cognitive user, and the technique behind this you call as the dynamic spectrum access technique. What are the basic functions of cognitive radio? In order to share the spectrum with the licensed user and also to meet the extreme quality of service without the interference, a cognitive radio user in a network, they must perform this following function. The initial one is the spectrum sensing, spectrum decision, spectrum sharing, and spectrum mobility. So what is spectrum sensing? Spectrum sensing, it determines the portion of the available spectrum. That is spectrum sensing. That is which portion of the spectrum is available. Next, spectrum decision. Now you have sensed the available spectrum. Now you need to select the best available channel. That is spectrum decision. Third one is spectrum sharing. You need to provide access to this channel with every users. So that is spectrum sharing. And final one is the spectrum mobility. So once a primary user or a licensed user is being detected, this cognitive user must vacate that spectrum. That is spectrum mobility. So this is a cognitive cycle depicting the functions of the cognitive radio, like what I have told you now. The radio environment, which is giving an RF stimuli. The spectrum is being sensed, that is the detecting the unused spectrum. Then the holes are detected, and second function is spectrum decision. You are capturing the available spectrum. Then based on the channel capacity, you are sharing the spectrum, and finally the signal is being transmitted. Also the final function, I mean the spectrum mobility, it is intercorrelated with spectrum sensing. Since because spectrum sensing function, it also detects the primary user. Only if the primary user is being detected, the cognitive user can vacate the spectrum. So the spectrum mobility and spectrum sensing are intercorrelated. When the primary user arrives and the cognitive user is terminating the place, but we have to see that seamless communication is being maintained at that particular time. What are the characteristics of cognitive radio? First one is a cognitive capability, a reconfigurable capability, and the self-organized capability. Cognitive capability. The first one is the spectrum sensing, then location identification on the network. Next one is the reconfigurable capability. So what is the reconfigurable capability? Any radio which is able to change its application when it is under operation. So that is the reconfigurable radio, and the function you call it to be as a reconfigurable capability. It is mainly used to realize the adaptivity required by the cognitive radio. What are the functions under reconfigurative capability? First one is frequency agility, dynamic frequency selection, adaptive modulation or coding, transmit power control, and dynamic system or network access. Frequency agility. So the radio which is able to change its operating frequency, that is frequency agility. Dynamic frequency selection. You are selecting the appropriate frequency based on the sensing results from the transmitters. That is dynamic frequency selection. And next one is the adaptive modulation and coding. The physical layer, that is the lowermost layer of the OSI model, it selects the appropriate modulation technique, either a binary phase shift keying or a quadrature phase shift keying, QPSK, and the necessary coding method needed to achieve the required spectral efficiency gain in the cognitive radio network. Fourth one is the transmit power control. In order to minimize the interference of the licensed user, the transmit power of the cognitive radio, it must be controlled by using the information of the spectrum sensing. Because in cognitive radio, the different users compete for a limited resources in an opportunistic manner. So they interact with each other in order to access the available resource, which causes interferences. This interference can be controlled by controlling the transmit power of the cognitive radio. And last one is a dynamic system or a network access. The spectrum sharing enables the secondary user or the secondary system to dynamically access the frequency bands without modifying the devices or any network in the primary system. That is dynamic system or a network access. Next characteristic is self-organized capability. Self-organized capability is nothing but You're providing more intelligence to the terminal devices. Communication terminal devices can be a mobile station. So this cognitive radio, it must be able to self-organize the communication based on the reconfigurable functions. See here, this picture, there are too many mobile stations connected to an access point, a tower. Since an emergency situation arises here near the base point or base station 1, this mobile station, they reroute themselves to the nearby base station or an access point. So what they do, they self-organize themselves. This is the self-organizing capability of a cognitive radio. Next, you are going to see the cognitive radio networks architecture. The basic components of CRN are namely the mobile station, base station or the access point, and the backbone or the core networks. So based on this, there are three kinds of network architecture. First one is the infrastructure based, ad hoc architecture, and mesh architecture. So what is an infrastructure based? Infrastructure based is the mobile station, it can access to a base station or an access point in a one-hop manner. That is, multiple hops are not permitted. This mobile station, under the transmission range of one base station, they can able to communicate with each other through the base station or the access point. Also, the communication can happen between the different cells through routing via backbone or the core networks. The access point, they can also have multiple communication according to the demand from the different mobile stations which are in use or which are in that particular network. A cognitive radio terminal, it can also access a different communication system through the base station or the access point. This is a picture depicting that the base station, there are two base stations. They can be connected to different mobile stations. It can be a mobile or a laptop or a PC, anything. And these two base stations are connected with each other with the help of a backbone or the core network. This is an infrastructure based. Next one is the ad hoc architecture. Ad hoc architecture, there is no infrastructure support. So if a mobile station, it recognizes that some other mobile stations nearby, they can automatically connect and they can form a link. This communication we call to be as an ad hoc communication, or the architecture is an ad hoc architecture. So in addition, a two cognitive radio terminal, that is a two mobile station, can also communicate with each other by using a existing communication protocol, for example, Wi-Fi or Bluetooth, or by using dynamic sharing. This is an example of ad hoc architecture of a CRN. There are no the base station or the access point. There, simply the mobile stations are connected without any infrastructure support. Next one is a mesh architecture. It is a combination of infrastructure and the ad hoc architecture. Similar to, we can say that as a hybrid wireless mesh networks. So the base station which you have, it acts as a wireless router and it forms a backbone for that wireless network. This mobile station can access the base station or the access point directly or by using Wi-Fi through different mobile stations. This is a mesh architecture. You know, mesh is always too many interconnections, right? This is a base station or an access point. Here another base station for this transmission range. There will be a gateway. Gateway is nothing but the backbone network. So here the mobile stations, or the devices, wireless devices or your wired devices, maybe your PC or a laptop, they can also be connected with each other and the communication happens between the devices with the help of this base station and the gateway. So what are the security issues? There will always be some pros and cons. If there is too much advantages, then there will be some disadvantages also in any network or anything. So there are some security issues. The question is how to protect the licensed spectrum and also how to protect the users and how to avoid the how to avoid the unlicensed user from causing the interference with the primary users. So what we can do, we can use any special reserved frequencies for emergency services. And also other possible risks are involuntary downloading of the malicious software. Malicious software is nothing but a malware, you can say. So malware is a software, it is intentionally designed to cause any damage to a computer server or a client. So this malware is being involuntarily downloaded. That is one of the security risks. And the other one is the licensed user emulation. You can also tell it to be as a primary user emulation. What is the primary user emulation? Is the malicious secondary user, it exploits the spectrum access etiquette by mimicking the spectral characteristics of the primary user. It acts like a primary user and it uses the spectrum, but it is a malicious one. That is a primary user emulation. Next one is a cognitive radio network applications. Cognitive radio networking, it can be used in a variety of applications. Some of them are listed below. And first one is a cognitive mesh networks, then public safety networks, disaster relief and emergency networks, battlefield military networks, and the leased networks. So what is a cognitive mesh networks? Generally, the wireless mesh networks, it is always being challenged by the scarcity of the wireless bandwidth. Only to avoid this spectrum scarcity, we are going into cognitive radio. So this wireless mesh network, it is challenged by this scarcity of the bandwidth in order to meet high speed requirements of the existing applications. Thereby allowing what it do, it allows the mesh nodes to dynamically explore the available spectrum so that the spectrum efficiency or the spectrum utility can be improved. Such cognitive mesh networks, they are mainly used to provide the broadband access in the rural and the tribal areas and are also in the under-resourced regions where the bandwidth is very minimal. This is an example of a cognitive mesh network, an internet which is connected to a gateway node. The gateway node, it is further connected to different mesh router. The mesh router is nothing but your modem which you use in your home. This mesh router, it is being further connected to your PC, or if it is a wireless one, if you are using Wi-Fi 802.11 standard, then through via the access point, it can be connected to the different wireless devices or the wireless clients. Also, this mesh network, it is not only used for the Wi-Fi, also it is used in the WiMAX. So WiMAX in the sense, the same thing, the mobile mesh router, it is connected to a base station. Since the WiMAX is a long range one, you need to have a separate base station for this. And you know the difference between Wi-Fi and WiMAX. Wi-Fi is 802.11 IEEE standard and WiMAX is IEEE 802.16. Generally, Wi-Fi is used for short range communication and WiMAX for long range one. And the main thing, the Wi-Fi can cover only several hundred meters, whereas your WiMAX almost nearly 40 miles or so. I'm not sure. The frequency, the main thing is the frequency. The Wi-Fi frequency, it is generally, the radio 2.4 gigahertz frequency it operates. And this WiMAX, it operates from 2 gigahertz to 11 gigahertz frequency. So which is more, you have different, the spectrum is very large. So next one is the public safety networks. Also this cognitive network, they are used in the public safety purpose for the communication among the police officers, fire personnel or the paramedic personnel. This public safety networks, they have a certain license with a variety of frequency bands. For example, VHF. VHF is very high frequency and UHF is ultra high frequency. The very high frequency itself is categorized into two, VHF high and VHF low. Likewise, UHF is also high and UHF is low. This low band VHF, it operates in the frequency of 49 to 108 megahertz, and the high band VHF in the range of 169 to 220 megahertz. Whereas the low band UHF, that is ultra high frequency, it ranges from 450 to 806 megahertz, and the high band UHF, it ranges from 900 to 952 megahertz. So this VHF low, VHF high and UHF low and UHF high, it is being used for the public safety. This is a picture depicting the public safety networks. Just there is a WiMAX base station which is being connected to different buildings like a municipal building, a remote government building, and public safety, that is a mobile vehicle. Then this one is a internet service provider or the backbone office, back office. And there are different departments like fire department, some hospitals are there. All these are connected and they operate with the help of the frequencies, and the spectrum sharing here occurs with the help of the cognitive radio. So the base station or the gateway, it is designed with an algorithm, with some cognitive radio algorithm, so that the frequency is being shared with all the users in the network. That is a public safety network. Next one is a disaster relief and an emergency network. We know that natural disasters can happen, or any unpredictable phenomena. It causes the infrastructure to collapse. So how it will get collapsed? For example, the base station of the network, it can fall. The connectivity can be lost. Some wireless LAN can be damaged. So in that particular place, if there is an urgent need for a communication to help any rescue team or fire service or rehabilitation efforts, what you can utilize cognitive radio network in such emergency situation. It can provide a significant amount of bandwidth which can handle a huge amount of voice and data, and also other sensitive traffics in that particular emergency situation. Here it is a network, emergency network. There is a back office here. These are the mobile network nodes. There are two, MANET 1 and MANET 2, mobile ad hoc network 1 and mobile ad hoc network 2, which are connected with the help of a satellite, and the information from the place is being carried over by the satellite to the back office. The cognitive radio is also used in a battlefield military networks. So when you come to the military networks or an army force, generally a reliable and a secure communication plays a mandate role. Yes, that is one of the more challenging tasks. Communication between the soldiers and the armed vehicles or the other units in the battlefield, or also between the headquarters, happens in a battlefield network. So this network does not only require a bandwidth, okay, but it also mandates a secure connection, since there will be a situation to carry the vital information, since it is a military application. So the cognitive radio, it is a key enabling technology which uses opportunistic spectrum access to fulfill the bandwidth and the reliability needs with a secure communication. Last one is the leased networks. So far we have seen that the secondary users is exploiting the resources of the primary networks, but they are not beneficial to the primary network in any way. So this primary network, it can be benefited. How? By leasing or by giving a fraction of its spectrum to the secondary operators, adopting the CR technology to access the spectrum. By leasing a fraction of the spectrum, the revenue of the primary operator, it gets increased. Naturally, the efficiency will be improved for the primary network. This is a summary of the CRN applications. Here is a video showing the application of CRN in transport. Yes, you have seen a video, right, regarding the applications of CRN in transport, which is being currently implemented in US. Next would be the future research direction. Future research direction, and first the seamless spectrum handovers, then proactive spectrum selection and interference avoidance, alternatives to the common channel, increasing the energy efficiency and the validation of the CR protocols. All these spectrum handovers, it is usually the frequency change that happens due to the appearance of the primary user, and also the interference avoidance. The interference can be avoided by controlling the transmit power of the cognitive radio, and the energy can be improved. The efficiency can be improved once for all if you control the transmit power. And the final thing is the validation of the cognitive radio protocols. Usually this CR protocol, they are implemented in a GNU test bed, GNU radio you can say. Using a software-defined radio technology, which is a flexible radio platform, it can be configured in the cognitive engine to transmit and receive different incompatible radio standards. There are also network simulators like NS2 and NS3 in order to design the network. This GNU radio, it is actually very useful platform for the implementation of SDR, that is a software defined radio, which is one of the basic requirement of the cognitive radio. Using this GNU platform, you can implement all the telecommunication modules such as filter, mixer or a modulator using the coding in either Python or C++. And also you can develop any algorithm to control it. So this is the validation of the cognitive radio protocols, and finally my conclusion is we have seen the characterization of radio spectrum, then how the radio spectrum is being efficiently utilized, what are the characteristics of cognitive radio and what are the important functions, then how the wireless channel, what are the different parameters that affects the architectures. And there are also architectures like a centralized or a distributed one. And that's all.
Thank you, ma'am. Thank you.
Yes. Thank you, sir. At this juncture, I would like to render my sincere thanks to VHNS Nadar College, Virudhunagar, and Pearl Foundation, a foundation for educational excellence, Bangalore, for giving me this excellent opportunity to deliver each lecture to a huge number of participants here. As a researcher, I would like to quote a thing. If you have got an idea, start today. There is no better time than now to get doing. That doesn't mean quit your job and jump into your idea 100% from day one. But there is always a small progress that can be made to start the moment. Hope you enjoyed the session. Thank you.
Thank you, ma'am. Thank you.
Thank you.
Monisha, congrats, ma'am. Monisha, congrats.
Thank you. Thank you.
Any questions, please? Okay. Now it is the time for vote of thanks, I think so. It's my great pleasure to have this one. Can you have any words on this? Three sessions.
Yeah, just to comment,
Yes,
the first lecture by Professor Jaykumaran, I think he is wonderfully, projected the utilization of the solar power, the solar energy, how to tap the energy, which are, ample in our Indian conditions, of course, in the tropical region, and how best we can use the solar energy for various application point of view for the benefit of the human kind and also for industry. I think you have very, very nicely quoted with almost to cover the entire the application aspects of the solar energy. My heartfelt thanks to Dr. Jaykumaran sir.
Thank you.
Next, my sincere thanks goes to Dr. Thangavelu. And in fact, he has given the overview of the environment status of today and what is the crisis now, and starts from the basic until to the global warming, and then I think he projected the whole sustainability issues and how to tackle all those things in the environment he projected. So my heartfelt congratulations goes to Dr. Thangavelu for projecting the state of art of the environment today. And the third speaker, Ms. M. Monisha, and I think he has talked about overview of the technology, what are the current, the frequency of the various sources available, and how best the frequency of all those can be used as the radio cognitive networks and application. Of course, this is one very important for the remote areas, where especially for the war fields, and then also communication sector, transportation, and then also this will be very much useful for the other planet also. I think in future we can use this for the planet also. We can connect Mars and then we can also having almost all the planets we can work out. I think the time will come. We will have a interactive network with the all planets. Hope Monisha will do that job. My congratulations goes to Monisha for the excellent presentation. So altogether, my congratulations, and then our the appreciation goes to the management, the VHNS management, the principal, the HOD, the dean, and then other. I think I should appreciate and congratulate all the team, the technical team, starts from the madam, and then Angu Selvi, and then to our all brave, etc. I think you excellently you have covered, and then excellently you monitored, and then excellently you have covered the the whole show. So I think the credit goes to all to the team of Dr. Jaykumaran, Dr. Prithviraj. Thank you, one and all. Nice.
Thank you, sir. Thank you, sir. We are also very grateful to PL Foundation, Education Excellence, because they are only giving the right recognition throughout the last 10 years for the right persons and throughout India. That much of appreciation, recognition make us to do some good things to positive way. So we are very much thankful to PL Foundation for their wonderful support throughout the last few years, for the very good personalities to come and together. And very much thankful to our management, our principal, Dr. P. Sundarapandyan, our HOD, Dr. N. Virudhunagar for their wonderful support to make this meeting a great success. And to all the resource persons from our side and from that is from Salem University, Periyar University, Dr. Thangavel and Mrs. Monisha, they have covered this environmental aspect and the technology aspect of the cognitive network. Thankful to one and all. I think Bharat is on the line to deliver some words. Yes, come.
Bharat, just to introduce. Bharat, just to introduce yourself.
Okay, sir. Good afternoon, everybody. Myself, Dr. Bharat Singh. Basically, I am from Government Degree College, Ramban, Jammu and Kashmir. I would like to congratulate VHN Nadra College and Pearl Foundation for conducting this wonderful webinar. Thanks for bringing all of us together on this virtual platform. My special thanks to my respected mentor, Professor Dr. K. Muthuchalian, formerly Vice Chancellor, Periyar University, Tamil Nadu, Pro Vice Chancellor, Dayanand Sagar University, Bangalore, for wonderful support and always providing me good opportunities. Thank you so much, sir, for sending me this important link. And finally, I also would like to thank Dr. N. Jayakumaran, Dean Research, VNH Nadra College, for the nice small introduction in the beginning of this webinar. Thank you so much, and congratulate to all of you once again for bringing all the resource persons and experts were nice and excellent topics have been discussed. Congratulate to all of you. Thank you so much.
Thank you. Thank you, Dr.
Bharat. Thank you, Dr. Bharat.
Thank you, sir. Thank you.
Thank you, one and all. Thank you, one and all. As in the part of research, our college is doing around some 10 departments as a research specialized area, both in science and arts, physics, chemistry, botany, zoology, microbiology, computer science, and commerce, management, and English. All the participants, those who are interested, kindly join with us. Our research departments are open to all. We make use of us through our website, our college website available. This seminar, the webinar also uploaded in our YouTube channel, college official YouTube channel. You can connect with that YouTube channel at any time. Thank you for the PL Foundation team and other members and secretary. The certificates will be sent to you all by within 2 days, maximum by tomorrow.
Congratulations, sir. Congratulations, sir.
Yes, tell sir, come sir.
Sir, myself is Murugan from Zonal Institute of Education Training, Mysore. So,
Okay.
the entire faculty members of my institute have watched your program.
Thank you.
And Professor Muthuchalian, especially thanks to him, because he is keeping the energy science alive.
Yes.
And
He himself is an energetic man.
thank you, sir. Thank you so much.
Thank you, sir. I think Neil Gande from Bombay is very much keenly watched throughout. He is very much keenly watched this program Bombay. So I am very much thankful to all the participants.
Sir, we have watched, sir, because we need energy science more here.
Yes. Any support from us, you please call us.
Yeah, right, sir. Right, sir. Thank you. Thank you.
Sure. We are having a wonderful renewable energy base in our college itself. With
Right,
the support
sir.
of our Dr. Muthuchelian and our team, School of Energy,
Yeah.
Madurai University.
Yes, sir. Especially regarding that Monisha's
Yes, cognitive network.
collection
Yes.
was very good. Yes, information.
Thank you so much, ma'am.
And budding scientist is coming.
Right, sir. Right.
Thank you, one and all. We all meet again in some other meeting by this month itself with the support of this team in computer related area by 26th, I think. Yes, sir.
Yeah, Jaykumar,
Yes.
you finally introduce Monisha.
Yes.
Who is she?
Yes. It's my great pleasure to introduce the great scientist Monisha, the cognitive network technology resource person, daughter of Muthuchelian. She is the daughter of Muthuchelian. The proud father is watching his daughter's presentation and webinar. We are all congratulate Dr. Muthuchelian and Dr. Monisha.
Thank you, sir. Thank you so
Okay.
much.
Thank you.
Yes,
Wonderful talk given by Dr. Monisha, ma'am.
Thank you, sir. Thank you so much.
Okay. Thank you, Dr. Thangavel sir from Periyar University.
Thank you, sir. Thank
Sir,
you very much.
Thank you for your team and other members. It's a teamwork. Thank you, one and all. Sir, thank you, sir. Thank you. Let us end up this session, sir.
Okay, thank you, Dr. Jaykumar.
Namaste
Thank
to
you. Namaste.
Thank you, sir.
Namaste.
Namaste. Shall we leave, sir?